we want to evaluate each of the limits. First limit, we can try some direct substitution. If we allow x to equal 0, we have the square root of 2 on the top, minus the square root of 2 is 0, divided by 0. Okay, so 0 over 0 is an indeterminate form, meaning we've got to do something else in order to evaluate the limit. In this problem, since it's a bunch of radicals, rationalizing the numerator is a good option, so let's try that. In order to rationalize the numerator, we need to multiply by conjugate, which is going to be the square root of 2 minus x plus the square root of 2 over the square root of 2 minus x plus the square root of 2. The key there is to have these signs opposite each other. So then we have the limit as x approaches 0 of distributing this, because we are multiplying the whole top by the whole top, so we have to FOIL. So distributing this gives us 2 minus x. The inside and outside terms cancel out. That's the whole reason for doing the positive and the negative like we did. And then the last terms give us a negative 2. On the bottom, we are going to leave it factored, since the whole reason we're doing this is we are hoping to cancel out the reason for the 0 over 0. That is, we're hoping to see an x in the numerator and x in the denominator cancel some things out. So we've got a positive 2 and a negative 2 up top. And then also up top we have a negative x. And then the bottom is the bottom. Now that we've gotten everything out of the top except for just the x, we can simplify. X divided by x is 1, so we still have a negative in the numerator. Notice I am writing limit every time. Since there are still x's in the problem, I need to continue to write limit because I have not taken the limit yet. Now that I have it at this point, now we can use direct substitution to find the limit. So negative 1 over the square root of 2 minus 0 plus the square root of 2, or negative 1 over 2 square root of 2. That's the answer to our first one. So for our next one, we've got an absolute value function. And with absolute value functions, it's helpful to write an absolute value in terms of a piecewise function. So the absolute value doesn't do anything to the function if the argument is positive. That is, if x is greater than 4, then x minus 4 is going to be positive, so nothing changes. Now, if the argument is negative, then the absolute value makes it positive. And the way we do that is we make it the opposite. That is, if x is smaller than 4, x minus 4 is negative, so we take the negative of that. Now, taking a look at our limit, we have the limit as x approaches 4 from the left. So that minus sign says we're approaching 4 from the left, which means x is smaller than 4. So I'm going to use the opposite of x minus 4 in place of my absolute value of x function at the top. Well, that pretty much solves the problem, because now I have x minus 4 over x minus 4, which simplify to 1, and we're left with the limit as x approaches 4 from the left of negative 1, which is negative 1. On the other hand, if the question had been worded like this from the right, now we would have to use the x minus 4 since it would be positive already, and then this would give us, skipping a step, this would give us 1 as our limit. And if you were to sketch this graph, you would see a jump in the graph at the point when x is equal to 4. Of course, the function is not defined at x equals 4, but on one side you'd see a -1, and on one side you'd see a +1.